Welcome to Radiance Sky Solar Tech channel. I'm super excited to have you here. So in this channel, we share concepts, system design, sizing, practical installation, product reviews, and tips on solar energy for electricity. My name is Chukwudi Emmanuel Onyewuchi. You can call me Engineer Chuks. If you are joining us for the first time, make sure you subscribe to the channel and also use the comment section to share with us what you are learning on the video, okay? So let's get started with today's topic. Welcome to today's video. So let's learn about solar radiation and photovoltaic fundamentals. So these are basic terminologies you should understand, okay, as a solar installer, as a solar engineer. I can bet you a lot of solar installers don't know about solar photovoltaic fundamentals, like the basis of solar radiation, like how solar is made possible to the earth's surface and all that. A lot of people don't understand this, okay? So, and this is very, very important. It actually will help you sound professional. Actually, if you go to write professional exams on solar energy and all that, these are questions you are going to be asked, because this actually shows that having knowledge about this actually shows that you understand the science of solar, you understand what you are working with, okay? So to help you understand solar radiations and all that, there are some basic solar terminologies you need to really understand to really know how solar energy is made possible. So you need to understand the role of the sun, okay, the role the sun plays in it. You also need to understand what is called solar constant. You also need to understand what is called solar irradiance. You also need to understand what is called solar isolation. So in this video, I'm going to take time to explain all these concepts for you, so you also know, okay, how to do some basic calculations. So understanding all these basic terminologies is going to help you in so many ways in your solar journey. So let's start with the sun. So let's understand the role of the sun in the solar system, okay? So first, you need to understand that the sun is the primary source of solar energy. So when you're talking about solar energy in any form, whether you're talking about solar energy in producing electricity or producing heat, sun is actually the primary source, okay? So if we say the sun is the source of every solar energy, how does it make it possible? So the sun emits energy in the form of electromagnetic radiation, mostly visible light or infrared or ultraviolet. So this is how the sun, okay, produces this solar energy we talk about. So another thing you need to know about the sun in the role of solar energy production is that the solar radiation that the sun produces, it reaches the Earth's surface at an average of 1,361 watts per square meter. This is at the top of the atmosphere. So this is actually what is called solar constant. So the solar radiation the sun produces actually reaches the Earth's atmosphere. The atmosphere of the Earth, not actually the surface, the atmosphere of the Earth. Okay, the amount that reaches the atmosphere of the Earth is 1,361 watts per square meter. Okay, this is the amount that reaches the atmosphere of the Earth. So this is what is known as the solar constant. So when we do calculations on solar, like for you to obtain the amount of solar energy you can produce with your panel and all that, this is actually the number that you work with. Okay, this is a figure generally acceptable that you can work with on when you have to do with calculations, okay? But this is actually what is called the solar constant, okay? So this is what you need to note about the sun in its role in producing solar energy to the earth, okay? So it does this with electromagnetic radiation like visible light, infrared and ultraviolet, and the amount that reaches the atmosphere actually, not the earth's surface. We have amount that reaches the earth's surface. The atmosphere is 1,361 watts per square meter. That's what reaches the atmosphere, okay? So take note of this. Now let's look at another thing I want you to understand now is also the solar constant. Remember, we mentioned the solar constant. We said that 1,361 watts is actually the solar constant. Now, what is the solar constant? So, solar constant is talking about the amount of electromagnetic area received per unit area at the top of Earth atmosphere, okay? When the Earth is at its average distance from the sun, okay? So, the amount of sun that reaches this top side, not this is the Earth's surface, itself, but at this top side now, this surface area, okay, the amount that reaches it. So when the sun is at average distance from this earth, the amount that reaches this area is what? 361 watt hour per square meter. That is actually what is called that is what is called solar constant. So in some areas it can vary, okay, depend on the temperature and all that. Okay, it can vary to 1412 per square meter. But there's another thing you need to understand. So 1361 is the amount that reaches the atmosphere. So if you're talking about now, before this thing gets to the earth surface, the earth itself, after some cloud has filtered it and some atmosphere have removed some of them, at most when the sun is very shiny at the sunny day and all that, is 1000 watts per square meter that reaches earth surface. Okay, so 1000 watts per square meter is what reaches the earth surface. And in most cases, this is what you use in your calculation when you are trying to calculate how many power your solar panel is going to generate and all that. You work with this measurement because this is atmosphere. This one reaches atmosphere, but before it gets to the earth surface, cloud and distance and everything must have filtered it. So the amount you should be expecting that reaches the earth surface is actually 1000 watts per square meter. Okay, so this is actually what is known as solar constant. This is the solar constant, 1361 watts. That is solar constant. So if someone asks you what is solar constant, you'll be able to tell him that is the amount of solar energy that reaches the earth atmosphere. Okay, but the amount that reaches the earth surface is 1000 watts per square meter. So is it noted? So another thing we need to understand now is solar irradiance. Okay, so let's look at what is solar irradiance. So solar irradiance is simply the intensity of sun power per unit area reaching the earth surface at a given time, typically measured on a flat surface perpendicular to the sun's area. So if you want to calculate like a certain amount of space, how do we know amount of power that is generated per square meter? That is what solar irradiance is all about. So basically you need to understand about solar irradiance is that it's measured in watt per square meter. You also need to understand that the average value, so you use the solar constant in calculating this. So we have discovered what the solar constant is all about. So if you are calculating solar irradiance, you use what? You use the solar constant, which is 1361 watts per square meter, right? So it also has a formula for you to calculate this. Now this is the formula. The formula is E equals to PA. So where the E is irradiance. So if you want to calculate irradiance, watt hour per square meter, is going to be power received, which is the watt. The amount of power you received, the amount of the sun is the amount of power, the amount of energy the sun is giving to the atmosphere. Then you divide it by what? The surface area. A is for the surface area, P is for the power received. That is how you get your E, which is irradiance. Okay, so I'm going to show you a simple calculation with this formula so that you really get to understand it. But before then, what is the importance of solar irradiance? Why do you need to understand it and all that? First, okay, you can use it to determine how much electricity or a solar panel can produce. Okay, if you do your calculation where you know the amount of sunlight that reaches the earth's surface of an area you want to install solar, so with that you can do your calculation and say, okay, this is the amount of power I can produce if I get so amount of solar panel. Look at, based on the sunlight that is reaching here, based on the amount of irradiance that is reaching here, or in this place, or in this location, or in this state, or in this region. Okay, if I should provide so panel, I will be able to achieve this goal. Or with this calculation, you can say, okay, this is the amount of solar panel I will be able to use to achieve so goal. So that is actually the goal of this irradiance. It helps you to know or determine the amount of electricity you can produce with your solar panel. And that thing also, it also helps you to size your solar panel. So in this case, you'll be able to know the amount of batteries, in the amount of solar panels you can use, the capacity of solar inverter you can use. All these things plays a role. If you can know the amount of solar you can generate, you can know the amount of battery that you can use to back it up, or the inverter that can supply the house, the load to the house. So all these things are very important. Okay, so you should also understand that on a clear sunny day, okay, in the afternoon, that is actually when you can measure this 1000 watts, which is the amount that reaches the clear surface. Okay, remember we said the constant is 1361, but before it gets to the earth surface, we will have about 1000 watts per square meter. Okay, but this is possible maybe around 12 o'clock when there is a very good sunshine. Okay, that is actually when you can have this result, okay, per square meter. So normally on a cloudy weather and all that, you can get up to 10 watts to 400 watts per square meter. Okay, so that is why you see that even when there is no much sun, your solar panel can still be working. Solar panel can still be charging even during rainy season when the rain is falling. As far as the sky is bright enough, you can still be getting some low or wattage or low performance from your solar panel, even though it might not be enough to power loads or charge your battery, but they will still be there due to the on a cloudy weather, the amount is going to drastically reduce. Now when you come at night, it's 0 watts. You don't get anything because the sun is already shaded by the night. Okay, so in that case, that's why your solar panel don't actually charge at night. Although there are new invention of solar panels today promising to offer solar power energy at night, but until they get to mainstream and being used everywhere, these are the basic things you need to understand on how solar energy work during the days and during seasonal times. Okay, so let's look at some of the basic calculations you can do. Let's say for example, we have 48 hours of solar power that falls on a 8 square meter solar panel. What is the solar irradiance? This question is simply wanting to know what is the square meter, what is the watt hour per square meter of this total power that falls on 8 square meters. Okay, so if you use using our irradiance, solar irradiance formula, E equals to P over A. So now I said that E equals to irradiance, which is watt hour per square meter. Okay, and that is what we are looking for, right? So I say our P is equals to power received. So our power received there is what? 4008. Okay, so A equals to surface area. So our surface area is what? 8 square meter, right? So if you do this calculation, we'll have our irradiance is going to be 4800 divided by what? Our square meter, which is 8. So if we want to ascertain the solar irradiance of this performance, okay, in a particular region or in a particular situation, we'll say that 600 watts per square meter, that is the solar irradiance. 600 watts per square meter. So when a question is thrown to you when it comes to asking you for solar irradiance, the person just want to know, or they want to know from you, what is the capacity of watt hour per square meter that is being produced. That is actually the question. Okay, and that is what we have achieved here. So in this case, the watt hour per square meter that is being produced in this total total solar power produced is 600 watts per square meter. Okay, so take note of this. So you can reward this video to really understand this calculation, but it's very, very, very important when you are designing, okay, your solar system. Okay, so let's look at solar isolation. Now what is solar isolation? So it's simply the total amount of solar energy received per unit area over a given period of time. Okay, so if I want to record, okay, the whole of Lagos State or the whole of Abuja or the whole of Nigeria, how many solar power energy did we receive in the last week or in the last 1 month or in the last 1 year? That is the essence of solar isolation. Okay, so solar isolation is always recorded in kilowatt hour per square meter because the amount of solar you can receive a day is definitely going to exceed watt hour. So everything is going to be running in kilowatt. Imagine I want to record in Nigeria or in Ghana or in South Africa how many solar energy that falls for the week. So the amount is definitely going to be in kilowatt hour. So that is why solar isolation is always recorded in kilowatt hour due to the size of data you'll be measuring, right? So another thing you need to know, there is a way you can measure, okay, solar isolation is actually your solar irradiance. Okay, that is your watt hour per square meter by times it by what? By duration. This DT here is all about the time duration you want to measure it. So solar isolation is also very, very important. Okay, it also helps you to make better decision. Also useful in case whereby you are designing a solar grid system for community or for a large usage. Okay, so you can use this data to actually have an idea of what capacity of solar energy that particular region produces. Okay, with that you can make proper decisions. You can know, okay, this is the amount of last month, you can say, okay, last month in this location, or in Lagos, or in Nigeria, this is the amount of solar energy that was produced. So anything you are designing, anything you are planning, you are going to work within that. Okay, you are going to work within that data. So all these things are for decision making. So the information about solar isolation in your state or country, you can always find it in meteorological stations or institution of your state or company. So these are people who document all this. These people who oversees weather and all that, they document all this. So this also is used to ascertain the intensity of heat during each of seasonal period. Okay, so let's look at some examples so that you can get a clear understanding of what I mean by solar isolations. Okay, so for example, if a surface receives 500 watt per square meter for 2 hours, okay, now we want to calculate the isolation. What is the total wattage? What is the total wattage of solar that has been received from this process? And to do that, you say formula equals to isolation equals to solar irradiance. Solar irradiance times what? The duration, the time period. Okay, now before you calculate this, you must have calculated the solar irradiance. Okay, so in this case, they actually gave us a solar irradiance. So this is actually a straight question. They have given us our solar irradiance. Okay, so this question can come technical. These are some of the questions they ask you in professional exams when it comes to solar energy, to actually know if you really understand this. So if they want to give you a technical questions, they can say, okay, 1000 watts solar energy fell on 2 square meter, okay, for 5 days or for 1 day. Okay, so they will ask you to calculate the solar irradiance and also the solar isolation. Okay, so you know what to do. You first of all calculate the solar irradiance. The 1000 watts, how many square meter? They say 2 square meter. You divide the square meter by the total energy, you'll be getting 5000 watts per square meter, right? That means you have gotten the solar irradiance. Then what you now do, they say for 1 day, right? If they say for 1 day, what you can do now is to times 1 day. Is you have to break down the 1 day to hours, which is 24 hours. All you can now do now then is to times the 500 watt hour you have calculated times 24 hours. You get the isolation. Okay, you get the isolation. Okay, but in this case now, they have already given us our solar irradiance. So what we need to calculate now is the isolation, which is, it says it run for 2 hours. To do this is simple. We'll do 500 times 2, which is the 2 hours. We'll be getting 1000 watt hour per square meter. So 1000 hour per square meter is also approximately equals to 1 kilowatt hour per square meter. Remember, we said that isolation is always measured in kilowatt per hour, kilowatt watt hour. Okay, is measured in kilowatt watt hour. So even though, if you are doing this calculation, even though you get this calculation, okay, you must convert it to kilowatt watt hour. Okay, so this is basic calculation. This is just an idea, okay, for you to understand how all these things is work. So if it means you rewatching this video to really understand this, okay, please do. Now, apart from that, you need to also understand, apart from the basic calculation I just walked you through, you need to understand that there are different types of isolations. So we have isolations which deals with you calculating total energy received in a day. So we might want to know what is the total energy received in so-so state, in so-so region and all that. These are daily isolation. So we also have monthly isolation. This is more like average daily values over a month. Okay, so we also have yearly, total of average energy received over a month. So with this now, you can know all this. Now you can know that, okay, this is the amount of energy that was received in a day, this period. In a month, this is the amount of energy that is received. In a year, during the raining season, during the sunny season and all that, this is the total amount of energy that is received. So you have all this data. Like I said, it's the meteorological stations in your country or state. These are people that have the right facility and capacity, the satellite and everything, to track all these things. Okay, and that is where you should go to get all this detailed information on these isolations. So there are barriers to isolations. That is, there are barriers to energy that a region can receive every year, every month, or every day. Okay, latitude, season, time of the day, cloudy weather, atmospheric conditions and all that, surface and orientations. These are things that can limit solar isolation. So where do you get useful data? Like I said, these are platforms online. If you go to energy data information, you get informations about solar isolation. There is another one called um, Global Solar Atlas, okay, info. They give you informations about isolations on different regions and locations, okay. So basically that is it on basic solar terminologies, okay. So I hope you have learned one or two things about solar fundamentals. These are what is called photovoltaic fundamentals. These are the basic concept, these are basic information you should have about solar energy, whether you are an installer or you're an engineer or even you're an end user. So this also helps you understand when your installer or your engineer is explaining a lot of things to you, it becomes clearer for you, okay. So having this basic foundation, you can now say, okay, let me start to learn the process of harvesting solar. You can also say, let you start to learn about all the materials and accessories that are used in harvesting solar. But these things are basics. You need to understand this foundational concept, foundational knowledge about how solar energy is possible, how solar energy is possible to us on this earth surface, okay. So that is it on this video. I hope you get one or two value from this video. So I will encourage you to subscribe to our channel. I promise I'm going to be creating more detailed conceptual knowledge about solar energy. We're also going to be talking about installations and all that. So if you are looking to learn solar energy for electricity, you're on the right channel, okay. So subscribe to the channel, share this content to anyone you know that is going to find it valuable, okay. Also comment on the comment section, let me know what you have learned on this video, okay. So that is it on this video, and I will see you in the next one.